Hello, in this video, I am going to talk about NPV, internal rate of return, and EAC. Let's start with a net present value, and let's look at this Excel sheet where I have an interest rate of 10%, which I have placed that value in cell C4. And then we have this project with 5 years of cash flows. The cost of the project is $1,000 in year 0, as you can see. And then the project cash flows are beginning with year 1, 100, 150, 200, 250, and 300. Now, what we are going to do is we are going to calculate NPV first using present value calculations, and then we will use Excel's NPV function to calculate the net present value. So in column D, what I have done is I have given you the present value of each of these cash flows. And since the initial investment value of this project is $1,000, and today that value is equal to itself, so the present value is $1,000. Now, in cell D8, I calculated the present value of $100 with a discount rate of 10% or with an interest rate of 10%. And to do that, I use the formula that is the future value divided by 1 plus the interest rate raised to n power. What we could also do is we could calculate this value using Excel's present value calculations. You can do that on your spare time. But here, I have used the mathematical formula for present value calculations. And then what I did is I have made sure that the discount rate stays the same at 10%. And then I copied down that formula and I calculated all the present value for each of those cash flows. And what I did to compute the net present value, I added them all up. So that cell is equal sum all the cash flows beginning with the initial investment, and that gives us that $277.83. And I can adjust the number of digits using these icons in here. I can eliminate all of the numbers after the decimal point, or I could make sure I have 2 or maybe 4 digits after the decimal point. Now you can see that when the project is taking $1,000 as initial investment, in the following 5 years, the cash flows that come in, they don't really justify this project. The value of this project is at negative $277. So we are going to reject this project. But before we do that, let's also use Excel's NPV function to calculate the NPV. And to do that, what we do is we use the NPV function, open parentheses, the rate is 10%, and then we put all the values beginning from year 1 to year 5, and then we add the initial investment at year 0. Now we don't have to discount that because that's already today. The initial investment is now, so that's why we are just adding it. And that's, as you can see, that also gives us, we made a mistake in our formula in here, as it gave us an incorrect value. Because it computed as a percentage when it should be a general number. So you can reformat that using the tools for formatting up here. And again, we have a negative $277 that we are going to reject this project. Let's look at the next tab. In here, what we have is we have 2 investment options given to us. The discount rate is 15%. And what we are going to do is we are going to calculate net present value for investment A and investment B. And then we are also going to compute the internal rate of return for each of these projects. And we are going to determine which one is the one this company should select. And we are going to also indicate the reason. So let me insert a row in here so I can recalculate the NPV so you can see it. Equals NPV, the rate is 15%, and then I am going to include the values from year 0 to year 5, all the cash flows, and then I am going to add the initial investment. And as you can see, I ended up with the exact same number as the row above. I can do the same thing for project B, for investment B, and the interest rate is still 15%, comma, I am going to include all these values, and I am going to add the initial investment for investment B, for project B. So you can see that project B or investment B generates a larger net present value, and that is the reason why this company should pick investment B. Now, to do the internal rate of return calculations, again, we are going to use Excel's internal rate of return, and this time we are going to include all the values beginning with the initial investment of this project. And you can see that I got the same value as the row above. And here again, I am picking the values for project B, and that's going to also give me the internal rate of return for project B. Now, in the case of internal rate of return, what we do is we compare these percentages that we just computed to the initial discount rate given to us, which in this case, it was 15%. And both of these projects, their internal rate of return exceeds the discount rate. But since the second project, or the B project, has a higher internal rate of return, we are going to pick that one. Let's go on. Let's look at this analysis where we have years 0 to 5, and we have all the payments, all the cash flows for this project. What we are going to do is we are computing the NPV beginning with the 0% all the way to 20%. And once we compute, and we already have an idea about, and I can include a row, a column in here, and I can show you how to calculate NPV one more time. The rate is 0% for the first one. The values are these values from year 1 to year 5, and I am going to include the initial investment. And as you can see, the calculation is equal to 5%. So in order to copy this formula, now I'm changing the interest rate, but I am keeping all the values of the payments or cash flows the same. So I'm going to use the dollar signs to keep all those values constant, and then I can copy my formula all the way down to get the exact same numbers that I have in column C. So you can see how I got that column, how I computed that column. Now, the next thing is we are going to plot the values of net present value. And to do that, what I can do is I can highlight this column where I have the values of net present value, and I can go into insert, and I can go into the line chart, and I can pick the line with markers. And that's, as you can see, that gives me this chart, which is pretty much identical to what I have in here in this Excel sheet that I have already prepared this chart. Now, in order to change the title, you can click on it and make the changes in here and type exactly what you want the title to say. In my case, it says internal rate of return is where the NPV crosses the x-axis. So you can see that that corresponds to 12% in this chart, where the NPV is crossing the x-axis. And then in order to change the horizontal axis, you can click on it and go up to select data. And for the horizontal category, you can pick these percentages that are listed in here in column B. Click on it, and then you can see that those are now percentages. Now, if you want to go further, what you could do is you could go to change this to format more so than what it is in here. And you could also change the intervals between the tick marks. For example, you could change that from 1 to 5. And then once you do that, you can see that it is going to the labels, actually, the specify interval unit from 1 to 5, and then that's going to reduce the labels that are in there from like going from 0% to 20% one by one. Now it's going at 5% intervals. So let me delete that, and you can regenerate that chart and make sure that you are able to do that using the data. So the next one is about making a yes or no decision. And in here, the interest rate is 11%. And we are going to compute the internal rate of return. Again, what we do is internal rate of return, and we look into all these values, and that is 31%. And the decision is to go forward with this project because it exceeds 11%. If you have two projects that you are going to compare, then you will compute the net present value and then internal rate of return. And then you will go with the ones that have a higher net present value and higher internal rate of return. Sometimes the projects will conflict each other, or the evaluation measures will conflict each other. And even though NPV may lead you to think that it's you have to go with project B, IRR may indicate that you have to go with project A. At times like this, your rule of thumb is to go with net present value. You have to go with what net present value tells you, and you will pick that project. In the next example, what I have done is, again, I have two projects, and we have plotted the net present value of these projects. And as you can see, we have that conflict in here, how to decide which project to choose when net present value and internal rate of return have contradicted each other. Then you can, like I said, you have to go with NPV. And you can see why NPV works better by plotting the NPV values for each project. Again, you can set your discount rate from 0 to, for example, 30%. Excuse me. And compute net present value for each project, and then plot. And you can see that there is an area where project A exceeds project B up to that point. So you could say that up to 8%, 8.5%, project A is better than project B. But after 8.5%, for discount rates higher than 8.5%, then project B becomes a better project than project A. And again, you can compute the net present value for each one of them, and you can plot these by going into chart. And in the chart, you could choose the line. And you can format your chart the way you want by changing the chart title, by adding the discount rate as your horizontal axis, and then you can change how frequently the horizontal axis labels are listed in your chart. I'm going to delete this. So you have to, and I highly suggest that you practice these charts so you can get better with them. And then you can see how one project is performing better than the other for certain discount rates versus the other discount rates, and you can make that conclusion. Now, there's an easier way to compute that 8.5%. To do that, what we do is we look at the differential between the two projects. So we are given the cash values for each project, and we compute the differential. And once we have the differential for project A minus project B, we can compute the internal rate of return for that differential. And you can see that that is going to give us that 8.5% or 8.51% right away without computing all the net present values for discount rates from 0 to 30% and then plotting it. This gives us a calculation way of computing that crossover point, which means that's the point where project A's internal rate of return is equal to project B's internal rate of return. And for these two projects, that happens to be 8.51%. Now, the last one in this workbook is when you have two different lifespans. And what do we do when we have to compare like two projects or two investments with different lifespans and different cash flows, obviously? So if we try to look at them in a equal plane, what we have to do is we are first going to compute each project's net present value, which is for this project A, the net present value is the cash flows. This project has 6 years, for 6 years plus the initial cash flow. So I entered too many. Okay, so let's say undo. Let's start over. NPV is 12%, comma, cash flows from year 1 to year 6, close parentheses, plus the initial investment. So then, in order to compute the equivalent annual cash flow, so in other words, in order to compare these two projects on an equal plane, what I will compute is the equivalent annual cash flow, and that is going to be equal to the payment function in Excel. And for that, I'm going to use the discount rate, which is 15%. And the number of years for this first one is 6 years. And then in place of the present value, I will use the net present value that I have computed a few minutes ago, and that gives me the equivalent, I'm sorry, I keep saying equal, but it's equivalent annual cash flow, or EAC. So you can see that I got that $125.68 for the first project. Now let me compute the net present value for the second project. The discount rate is 12%, comma. This project has 3 years or 3 cash flows, and then I will include the initial investment, and that gives me that $470.55. And then in order to compute the EAC, I'm going to use the payment function of Excel, use the discount rate of 12%, and this project has 3 years. And then as the present value, I am going to use the NPV that I just calculated, and that should give me that $195.91. And then since the second project is generating a larger cash flow or a larger EAC, I am going to pick project B. Hope this helps going through these Excel worksheets. Let me know if you have any questions, and I will see you in the next video.